Hello, everyone. Glad you are joining us in this breakout session. This session is around the hardware development and specifically around LoRaWAN hardware development. I'm excited to be having this session with you and Wienke and Orkhan. I'm a firmware engineer, Ahmed Elsalahy at the Things Industries. And we have Orkhan, our hardware engineer at the Things Industries, and we have Wienke, our CEO, of course. So in this breakout session, it's not as formal as the slides look like. So we're going to add some emojis and make it very informal. So yeah, basically we're going to cover 3 topics. The first topic is we're going to introduce the generic node for people who are not aware of it and give a short update on what's happening. Also followed up by a small demo. And afterwards, we're going to discuss and have a informal Q&A around LoRaWAN device development. And then maybe share some experiences and knowledge around hardware development. Super excited. I'm seeing the numbers rise up. So we have a lot of people joining. So that's cool. Yeah. So let me pick it up. So we're going to start with introducing the generic node again for people who are not familiar with what is a generic node. The generic node is mainly a device that is designed to go into production, and it's around the bigger picture called the generic node platform. And inside this generic node platform, there's 2 different hardware devices. The first one is the generic node sensor edition, and this is a hybrid device between prototyping and production. So this is a device that you can order and already use, and it comes with an enclosure and AA batteries. And the device features STM32WL SoC, which is the latest in the market for sub-gigahertz. Yeah, and it also acts as a reference design. So the entire hardware files are already released on our GitHub repository. And also the firmware boilerplate applications that can assist you with going into production are also available there. And yeah, you can use that reference design or use the applications that are built for your own use case. Yeah, so this is how the device looks like. We launched the device on the end of January in our The Things Conference 2021. It was an awesome launch. We had 100 prototype devices that we shipped out. Was great work by Orkhan and the team to make sure that we are actually showing that we already produced the devices and shipped them. We have people who are already contributing to our repository, people who are already testing the devices and reporting back. Yeah, so this is a short introduction around the generic node sensor edition. So let me also explain what the sensor edition has on board. So yeah, it has a sub-gigahertz SX1262 from Semtech radio. It has 256 kilobytes. It's really good for building complex applications. And it has also 64 kilobytes of RAM. So it can go to 22 dBm power output. It acts as a dual band device, so you can use it in Europe and the US, so 868 and 915. It uses AA batteries, and this is also aligns well with the theme of this conference, smart facilities, because you can easily change that and reduce the overhead. We can also ship the device to you, and you can buy any AA alkaline battery off the shelf. Yeah, so the voltage range is between 2.2 and 5.5. It features a secure element, a secure enclave that is pre-provisioned. So the secure element has internally all the keys and the EUIs you would need to scale. So you can buy 10,000 generic nodes and get just one file to onboard all these devices. Yeah, and also it features an accelerometer, a really low power accelerometer that basically can detect movements, any micro movements. It can detect any acceleration in any direction, and also features a humidity and temperature sensor. This is basically to also aligns well with the theme. So you can also use it for reporting whatever the environmental surrounding to report the temperature of the environment. Also features 16 megabit, 2 megabyte external flash. This is basically for that allows for photo and also data logging. So for example, you can put all the data of some sensor into that flash and then send just one packet at the end of the day. So it's really awesome for that. We have also a user button, an RGB LED, and the onboard buzzer. And basically you have an expansion port that you can just add any sensor that you would like. And here's where, like, as I mentioned, it's a hybrid device. You can use it for prototyping and then go into production. Yeah, and you can program it with any application that you have. Let me also a bit more on the software specifications. So we have multi-sensor firmware. We have bare metal applications, we have FreeRTOS applications, and we have Azure RTOS applications. We have just pre-provisioned secure element applications, so you just flash that and you join. We have basic bootloader, and we're also gonna support FOTA update clients. I think this is a short introduction on the generic node sensor edition. I don't wanna take too long around that. Maybe Orkhan can give us a brief overlook around the generic node tracker edition if he doesn't have a lot of background noise.
How's the sound quality now?
It's good.
Very good.
Okay, perfect. Thank you, Ahmed. Thank you for this nice info about the generic node sensor edition. Basically, tracker edition reuses many of the design choices from the sensor edition, and but as a radio transceiver, we are using LR1110, which is a newest chip from Semtech, and it has a very nifty features of doing GPS, GNSS scanning, and Wi-Fi scanning on top of the LoRaWAN. That allows us to have a very small, highly integrated device, which can do many of the things in one chip. And in this tracker edition, as I said, we reused many of the sensors and the power supply section, the flash memory, secure element from the generic node sensor edition. And all of this are enclosed in a small PCB of, as you can see, it's basically the same form factor as the generic node, and a very small size of 30 by 40 millimeter. And we are using one single antenna in a tri-band mode, and we are multiplexing it. That reduces the BOM cost and also reduces the device size, and so that we don't have to use 3 different antennas for the 3 different frequency bands. And right now it's a very early prototype. We are working on to verify the design, and later on we will also open up more design details.
So maybe the only thing I want to add here is that the vision and the product vision and the mission of this is more that when we have so much experience with running all these different devices on our platform, that we wanted to create a boilerplate of a device that has all the features of, let's say, a second generation LoRaWAN device. And this is not our intent to start competing with device makers, but it's our intention is to make sure that we have a reference design available that includes security, that includes using batteries that are part of circular economies, like AA and AAA batteries, because e-waste regulation is coming, something that is firmware over-the-air update, because 2 weeks ago, the UK government presented a, let's say, a trial legislation around IoT security, and it needs all IoT devices in the years to come need to have firmware over-the-air update and random keys, root keys, and that's why we have the secure element. So yeah, this it's all source available, so it's also serves as an inspiration, and any device maker can get in touch to see, okay, how can we work together, and we have very flexible license models here. So yeah, I think it's good to add to this, that we really see this as an ecosystem contribution as well to the device maker ecosystem.
Yeah, indeed. I think it's a great addition. In general, the generic node sensor edition and the tracker edition are both to support the community, and everything is publicly released. And we're also working with other suppliers and device makers to make sure that they can use these boilerplates and also launch different applications and use cases.
Yeah. So I think what we have already seen is that we have a few thousand people that are on the sign-up list to get their hands on this product, and we are I think there's already around 10 partners that are looking to incorporate this design of modules of this design, because they're also adopting the STM32WL, and yeah, if you're interested, yeah, feel free to reach out to us, and let's discuss how we can partner here, and how we can make sure that we get a second generation of LoRaWAN device that is more secure, more manageable, less e-waste, etc.
Yeah, awesome. So yeah, moving forward, I have a small demo for you guys, but I think it's better that we also get an update on the generic node sensor edition. So for anyone who's interested, maybe Orkhan, can you give us like an update and how it's going with the hardware and certification and sending the prototypes and stuff like that?
Sure. So we've sent more than around 60 nodes right now. For those were the high-risk beta testing units, and right now we're also going through a certification. We did the pre-certification. Basically, it passed all the tests. It was subject to very harsh conditions, like 4,000 volts ESD, and vibration testing, RF blasting, immunity testing, things like that. And it's been going pretty well. We are really happy with this. The only potential issue was a bit of with the antenna tuning, because we have on the close proximity metal screws, but with proper tuning, I think that will also we will overcome that, and we will pass the certification.
Yeah, indeed, we're communicating with our partner Ignion, I guess, for tuning the antenna and making sure that we have the perfect antenna for you guys. Yeah, awesome. So yeah, let me, with that short hardware update, I'm gonna also give you maybe a small demo on the software side. So let me break out my presentation mode. So I'm gonna head over to our cloud, our V3 stack cloud hosted deployment. This is the things stack. You can use it with any device, and I have my device here, for example. So I have something called normal device. You can call it anything. So yeah, I'm gonna navigate to that device. So what am I gonna do in that demo? I'm gonna show you like the generic node sensor edition operating. So if you are aware of LoRaWAN, everything is around security. So at the start, we do over-the-air activation, and afterwards, we send some packets. In this demo, for example, I'm going to send a couple of packets showing like the onboard sensors being active, and maybe send a downlink and see what if we can build a use case around that. So we're going to build an imaginary use case where we have the batteries are low and we need to replace them, or we have the temperature surrounding the device that is too high and we want to make sure that anyone surrounding that device are aware of that. So yeah, so let's pick it up and try it. So this is a live demo, so be nice to me. I hope it works out. So I have the sensor edition connected here to the power supply because you can connect it to the AA batteries, but I'm gonna power it now, and it should try to join. Yeah, so it's trying to join. So this is, if you are familiar with LoRaWAN, this is just trying to join. We're getting some nice RSSI here, and it's doing over-the-air activation, and it successfully joined. Maybe I can also make my screen a bit bigger in case you guys don't see what's happening. Yeah, so after it successfully joined, this is a console. So basically, this is rough raw data of what's happening. And yeah, I added a very simple payload decoder. And this payload decoder basically shows like what's happening right now. So yeah, the payload decoder basically sees, okay, there's a bunch of bytes, and I want to understand what these bytes mean. So it says, okay, after we decoded it, that the accelerometer X and Y, Z is like reading these data, and the battery voltage is 2.9, the humidity is 31.2, and the temperature is 26.5. Okay, so it's reading just some data, and yeah, so we can, for example, create this scenario where the battery voltage is like 2.8, for example. So right now, if I continue here, it's sending every 10 seconds now because I want to accelerate that demo. But yeah, this is for testing purposes, of course. So I'm gonna now change the voltage of the batteries, for example, the input voltage to 2.8. So yeah, let's wait for the message. It's still 2.9. Let's wait for the next latest message. So this is onboard. So the device onboard has its own battery voltage monitor. So let's imagine, so now it dropped to 2.7 because I changed it on the power supply side. For all the geeks out there, you can have a power supply around and try this yourself using our repo. And yeah, so it's 2.7 now, and we want to, for example, say, okay, please change the batteries. We want to change these AA batteries. So let's send it a message. And we have an onboard buzzer that basically helps us with that. So for example, if I go to downlink, and yeah, I'm gonna push some decoded value, and I'm gonna say like, I made it like BB. So in hexadecimal, just BB for buzzer. And basically, I'm telling it that this device, okay, this device is like the operational voltage is not too good. We want to change it. So I want to alert whoever is going to change the batteries. This is the device that we want to update the battery for. And then I'm going to schedule a downlink. And you can see I schedule a downlink. And yeah, if you hear that, basically it's a warning on the device side. It's a 2-second warning on the buzzer. Orkhan, did you hear that? Okay, should we try it again? Just yeah, this is risky because it's live, but I think it's worth the fun. So I'm gonna try to schedule another downlink. Yeah, so this is all using LoRaWAN. It's not using any other like serial connectors or anything. I'm glad you can hear it all.
We have to implement the Super Mario sounds on the.
Yeah, we can do like
MIDI.
Yeah, you can send a musical notation. Yeah, for sure, Nick. Yeah, so it depends on how hard you want to hurt your battery. But yeah, so this is just the demo. I hope this was fun. This is just to showcase that if you get your hands on the device, you can build a lot of use cases. For example, this can be a temperature going out of range. You can also add other sensors and you want to see an effect. So one of the cool things that the buzzer provides is that you can take an action around something. So instead of like just blinking an LED or something, you can actually have a physical reaction around what's happening and send that over LoRaWAN. So that is one of the cool things. Yeah, so jumping back to the presentation. Yeah, so this is a nice segue to just have a simple Q&A. We have a lot of people, so that's really awesome. Yeah, we have Wienke, we have Orkhan. Anything that you're interested in around LoRaWAN device development. For example, Wienke is struggling. He's now noticing the supply problem of different components with Orkhan, and they are making sure that for the next production batch of the generic node, they can like basically fix that problem. Yeah, maybe we can discuss that. We can also discuss like what other use cases you guys think of.
And Ahmed, what does somebody has? You have to press the button right on the screen to join this, and then we can add you to the panel.
Yeah, so definitely. So if you're interested in joining us, we can add you. If you wanna like
I saw
be part
somebody
of the moderator team,
or you can just ask your question in the chat. That's also fine.
Yeah. So yeah, if you wanna like have a longer discussion, we're happy to have you here. But if you also wanna ask a question in the chat, yeah, feel free. Yeah, so Dolph is also asking if we can go into the issues of supply, I guess. Yeah, the silicon shortage. Yeah, Wienke, what do you think? What's happening?
Yeah, so Orkhan has been quite actively with sourcing, and we're going to partner with a Chinese manufacturer, and yeah, definitely there are some issues. I think the advantage that we have in Internet of Things is that it's not in this like millions of volume that that's going to be hard. So the first batch is going to be 5,000 of these devices that we're going to produce. And then at 5,000, the components are still relatively expensive, of course, if you compare them, if you would do them at higher amounts. But yeah, it's definitely, and we hear it from a lot of partners as well, and that's definitely a problem. But I think also a lot of people expect there's light at the end of the tunnel, that it's going to be over in a matter of like half a year to a year. So yeah.
Yeah, do you have any like tips for anyone who is having a problem with that shortage? I remember you had a good experience reaching out to the manufacturer themselves.
So for me, I think the golden egg now is to have access to these components, and I think I think what Orkhan also did is he was really because he looked at components already when he designed it to be them to make sure they are not too exotic, let's so to say. So yeah, Orkhan, I think maybe you can share a bit how you incorporated this perspective in your design as well.
Yeah, definitely. So since the beginning, when we designed it, I tried to pick as much as the jelly bean parts, like the very popular parts, and by sticking to the popular parts, we have very small number of components which are high risk at the moment. So I believe there's around 78 unique components on the board, and only 5 of them were high risk or hard to obtain at this moment. And a couple of them we've contacted the manufacturer directly, and they were kind enough to supply us with their local inventory. But it's not that we have locked ourselves into one component. It's a very as the name implies, is a generic device. Therefore, the components selection is also very generic. We are really flexible with changing, replacing the components. Most of them have a interchangeable footprint, like they don't have a footprint sizes. It's very standard SOT 23 type of components that we can easily replace, because the part manufacturers, they are usually coming with parts with the same pin numbering, the same footprint, and if one is out of stock, we can always go to the other one. That does not apply to all the components, but at least most of them we are pretty flexible, and that is a big advantage. For Dolph's question, not at the moment, because it's a new chip and they already had the stock available. Maybe it is hard to get from big distributors like Browser and DigiKey, but STs, local FAEs, if you contact them, they will be happy to help you.
Cool. Yeah, so we have another question from Jose. He's asking how he can write some code for the STM32WL. So one of the cool things about ST ecosystem is that they provide you with a big SDK. So I'm sending you now the link to the examples they have for specifically for the ADC. I hope they help you out, Jose. I hope you're listening in. So basically, you can also navigate other examples, but basically, the STM32Cube package allows for a lot of examples around building applications for the ADC. Thank you, Dolph. So we have another question. What is the floor consumption of the board? Yeah, Orkhan, you're happy about that part?
Yeah, we actually, yesterday, we were a guest at the ARM's Innovation Coffee, and we did a live demo there, and maybe we can later share the video link.
Yeah, I can try to find it.
Yeah, so for the LoRaWAN example, basically sending packet every 10 seconds, and in our example code, the sleep mode current was around 1.9 microamps. So, but I believe it can go even lower than that. Ahmed, correct me if I'm wrong, but if you really go into like a stop mode 2 and disable everything.
Yeah, so one of the things that I remember that I can show you guys is that I have the OT files for that. So I have the OT file that basically allows us to see like how the power consumption looks like, and I'm gonna open it now, so you can see with me like what, for example, the demo that I just showed you with sampling the temperature. This is we send that file to OT itself, so we're working with them directly. So yeah, let me make it bigger, and you can see my screen. So I'm gonna zoom in a bit. Can you see, or is it too? Orkhan, give me some feedback on what do you see. Is it too? Is the lines too small?
The lines are barely readable, but
yeah. So maybe I can open a zoom lens to just highlight what's happening. So. So this is typically okay. So yeah, so maybe this can be seen. So if I do something like this, so this is the current consumption. So you can see here, this is the current consumption when it's sleeping. I don't know if this is readable for you guys, but I can try to zoom even more. Is it readable?
it. Yeah.
Okay. So yeah, so this is basically the average current consumption while it's trying to sleep. So this is when it was trying to join, and if you can see that part, this is where it's trying to join. It typically sends a big, so over the air activation, it sends all the UIs. So it typically is a bigger packet, and then it tries to attempt to sleep. And this is where I have the sampling, and it easily enters like an average current of 2.59, which is awesome work on the hardware and firmware, because this is an application that you can flash right away now. So you can just go to our GitHub and flash it. Yeah, so if I also go a bit to the right, so if I go a bit to the right, you can see that we sleep for more time, and this is the same sleep current, but then we send just sample temperature, and this is all with the new STM32WL chip. So yeah, again, we are sending some packets here, and then we're going to sleep. And if I navigate also to the sleep current, you can see that the average is always around 2 and 2.37. Yeah, so the node sleeps quite well. One tip to reach that voltage level is to deattach the UART and the debugger, because they consume some current, and you can reach that. And Orkhan, what is the, so how long can it survive on that measurement for AA batteries from your calculations? Orkhan, I think he has a connection issue. So just to give you, yeah, Nick is saying years. Yes, I agree. It's years on AA batteries, because this is, yeah, Orkhan, but this is all like, when he comes back, we're going to ask him again, but it's also really a good, so I think you can easily kill the battery physically and chemically before you can actually run out of battery. So the battery itself will die before you can actually consume all of it, because that is typical alkaline batteries. But you can also use other batteries. So we're also working with UTI and Koitek to make sure that we build some profiling around other batteries, such as lithium manganese and any lithium operated battery, so you can get more out of your batteries. Yeah, so I hope that was helpful to you in any way. Do you have any questions around that part? Yeah, indeed, Nick. So it really depends on also the temperature surrounding your battery. So, okay, so I'm gonna scroll a bit up so I can see the questions. Maybe I missed something. Yeah, so we have another question from Abhishek. He's saying that I would like to know if you have any guides for for STM32WL. So yeah, the STM32WL has so many documentation, so much documentation. So one of the things that I recommend, we just sent the link here. But if you navigate to this examples, you can see it. I sent the link here, so you can, if you navigate to these examples and you get a Nucleo board, it's a really good starting point, because you can just compile the application and use it. These are all examples that run on the STM32WL. And if you get our board, you can navigate to the generic node, the sensor edition repo, and you can also just flash the applications there. And when you flash an application and you also do some configurations, you will be able to understand, oh, this is how it works. If you want to read about it, the ST portal has a very nice set of documents and videos, tutorials, and you can also attend some of the sessions that we have in the conference, where they also like give you like understand how the STM32WL works and how you can start using it. Yeah, I think this is the best way for that. Yeah, Orkhan shared the YouTube series on the STM32WL, which can be extremely helpful. Okay, so let's see another question. Thanks, Nira, for the support. So we have Jose. Is your question answered by Orkhan? I see you asked question. Yes, we can share with you the OT power consumption. That is extremely doable. I think we can send it, and so we're gonna release a couple of articles on the generic, and we're gonna share that file there if that's okay with you. And we also will share them in the generic node sensor edition repo. So let me send you the link to these two, but we will send you the OT files. I don't think I can share the file in here, or can I?
No, Ahmed, it won't be possible here.
Yeah, we have an entire issue around like doing power consumption analysis for all the applications, because we want these applications to be used for production, and we want to validate that and also put a sample OT file that people can just use and also explore. So we're gonna have that, and we're writing these articles and adding them soon. So this is one of our targets. For the documentation, just follow this link in the future. Let me send it to you in case you're not familiar with it. And yeah, the generic node GitHub repo, I think you guys are all aware of it. Let me also send it. Yeah. Let me jump. Thank you for all the amazing words and encouragement from you guys. Thank you, Ewan or John. Super awesome. Yeah, we are also hoping that it will be soon available. So Jose is asking, when working with the chip itself, a direct connection to the antenna is fine. Orkhan, he's asking you, is it fine?
Replying him. So basically, the chip itself, so some chips have a very high integration for the RF section, like a ESP32 Pico boards, things like that. But this one does not have any. The RF output pins from the MCU has to go through certain RF matching and differential to single-ended conversion using some passive components like inductors and capacitors. But on the last stage of the RF path, there's an RF switch which changes the antenna from output to input mode. And right at the output pin of the, you can connect basically any type of 50 ohm antenna. And the RF switch has a built-in DC blocking capacitors already.
Yeah, super awesome. I
yeah,
hope, did we
have
miss
an
any
onboard. Sorry, Ahmed. Yeah. So we have an onboard micro UFL connector, so that allows us to connect if the user wants to have better transmission range, or by changing the resistor, it also allows us to test the antenna performance by bypassing the MCU and directly connecting the UFL to the antenna itself. That's how we do the tuning.
And this was helpful also, I guess, in the certification, right?
Mm-hmm.
Yeah. Super cool. Yeah. Any more questions, guys?
Yes, we will have a datasheet and a getting started guide very soon. But right now we were busy with the certification itself, but once we pass that, we will have all the required documentation ready as a PDF and also on our website.
Yeah, we have a lot of interest from the community on more documentation. We understand that 100%, and we want to make sure that we have everything from like power consumption to design details. One of the things that you can use is our GitHub issues. We typically just transparently say everything that we do there. Even you will find like Wienke suggesting something crazy, and we say, okay, we're gonna do it. So yeah, it's a lot of fun in that way. So you can also navigate in these issues and learn about our process. One of the things that we want to also share in the future is mostly that everything that we do is going to be documented, but right now we are in the beta phase, and we are still like settling down some design decisions. And after that, we will write very good documentation that basically gives you like a concrete guide onto how to build an application, how to build the antenna, and how to do all these things. But we need to try it ourselves first. So we have two questions. How much does it cost? From the same person. Yeah. Shamil. I think, Wienke, you mentioned yesterday it's...
Yeah, we had a question yesterday as well, and it of course depends a bit on the component cost. The first batch, we think it will be shipped between 30 and 50 euros, and at volume it will be lower. Yeah, what we aim for is to see where we can support other device makers in making more mature devices that include firmware over-the-air update, include secure provisioning, etc., etc. So yeah, it's a platform. It's more sort of a franchise, and the initial devices will be around 30 to 50 euros. But that will be interesting for smaller use cases. But yeah, once you go to scale, you want to really go into companies that specialize in industrialized products, and then of course that depends on how they use it.
Yeah, so yeah, indeed, I think when we scale it, I think so. For example, we have a lot of partners such as Compaq, and we have other partners that work with us on like scaling the product.
Ernas, for instance, and
and Ernas. And I think one of the key things is that if you feel that the generic node prototype is useful for you, or the production device and the enclosure and the design is useful for you, contact us, and we will make sure that you can achieve your use case. Basically, this is what we do. And if you scale it, it's gonna be way less expensive. So Nick is saying a version without the case for when we have larger sensors would be useful. Orkhan?
Yeah, it is definitely. Then it will be more like a development device. But one thing to mention here is that it changes the antenna behavior. So antenna will be tuned around the enclosure and the batteries. So, and if you take out the enclosure and the batteries from the equation, the antenna performance, the tuned frequency will shift quite a bit towards the 900 megahertz range. Later on, we can include maybe a short guide on how to retune the antenna if you're going to use it without the enclosure. It will be basically 2 or 3 component changes in the last stage in the matching network, and then if you want to get a better range. And the components are 0402 package. Might be a bit hard to resolder them, but they have enough clearance in between them so that wouldn't be so hard.
Nice. Yeah, so yeah, let me jump to the next slide, which is a roller coaster. I tried to make this fun breakout session. So yeah, so basically you can still keep asking questions, of course. Nick is saying that he have soldering his genius in his house. Okay, so that's awesome. So yeah, exactly. So that's actually a good segue into like sharing experiences and knowledge. Um, Maybe Nick, you wanna join us in the chat? Yeah, maybe Wienke, can you add him? Maybe do you see him
Yeah,
requesting?
Nick, you have to add yourself. I think the top right,
Yeah.
there's a button, and then you will appear on our screen, so we can add you. Yeah, here you go.
Yeah.
Hi, Nick. Yeah, we can hear you now.
We can hear you. Yeah. So
Yeah, we can hear you thinking. So
he has another Zoom session running. That's fun.
I'm muting Nick. So then I don't think he can in. Yeah, so he's muted. Nick, so if you want to say something, unmute yourself.
Yeah, so we're sharing like some of the experiences. So yeah, maybe I have an experience. Maybe I can start off with that. So yeah, so one of the things that happened is that we had a new teammate joining us. His name is Marnix. He's one of the people contributing to the repo. And the first task was basically build a freefall app. And you can see the freefall app in the repo. And yeah, I remember him asking like, how can I test that? Yeah, so he's like just joining and he's trying this new hardware and he's like super worried about how can I test freefall without breaking my board. And I'm like thinking, what are your like thoughts around that? Like, how can you test freefall without like building this massive jig and like going crazy at it? Because
just tell him to drop it from height onto his bed.
yeah, this is what he did. This is what he did. But I really can't imagine an environment where you're building application and testing and then going to your bed to try it and then coming back and connecting it again. It must have been really hard. Okay, so
Okay, that was your experience. But you have to get physical with IoT, right? You have to, yeah.
yeah, it's crazy. I felt bad after like suggesting that application. So we have Nick trying to join again.
Hey, Nick.
Hi.
Hey. How's your cave?
It's good. It keeps varying in temperature. It's global warming, but yeah, just reaching for my generic, the main generic node. I haven't let out the magic smoke yet, but
Okay. Well, what's your experience so far? Give us some feedback and yeah, you don't need to be kind. We're Dutch. We're Dutch, or at least our company is Dutch, but that's not enough.
Go on, Wienke.
we can take some criticism. How did it?
I'm quite a small hardware and software developer, and I generally get given things by clients who need things unraveling. And as you can tell, I'm well, I don't know if you can tell I'm old, but I'm an elder geek. I'm in my early 50s. So I see many things. I mean, this is a really nice designed board. It's it's not too big. The boards that I make are called tiny things. They're about half the size of this. Some boards are really big and you just can't get it into a case at all. So it's all nicely laid out. As you can see, mine is out of the case, and I've got my own wiring loom set up for the ST-Link and serial debugging.
Nice.
But the main thing is that because you implemented the whole environment on the Visual Studio Code environment, I could get into it so much easier than. So this is an iMac. There's an iMac screen here. There's a Windows machine here. If I'm doing microchip, it's on the Windows machine. If it, whereas I've got that flexibility to be able to just pick up the machine and just, it doesn't matter which one it is, so I can just get on with it.
I have a Windows laptop just for microchip tools.
But also the Visual Studio Code environment, because you use it for other things, you're a bit more familiar with it. So every time I'm in what's now called Microchip Studio, I'm tripping over where the buttons are. And the environment for me as someone who writes software is important, because I spend a lot of time writing code, debugging, downloading. It's all there. If I need to, I can drill down into the source from Semtech or what have you, but it's not in my face, because sometimes you open up a folder and you just look at all these files and you think, aha, where do I start? So nice looking board. Schematics are amazing. I think I've already I said that somewhere else. I don't know if I cut JP2, do I stop loving it? Is that the buzzkill?
Yes.
Was that a joke in the schematic?
Yes. Basically it does. You get to use the GPIO pin.
Oh yeah, no, I know why it's there. I was looking at the schematic a couple of days ago, and I saw that it said buzzkill, and I just thought, okay, a little joke.
That's actually a good joke. That's actually a really nice joke.
I'm hoping to have this or one of these. So I've got another one mounted outside on solar shortly as a permanent fixture.
I think Nick, you have like 3 boards, right? You have like 3 generic.
No. Let's not tell people how many I've got. Otherwise, they'll come round to my house and ask for some spares. But yeah, one is destined for running a small solar in the garden. There's I've just got a different water probe arrived today, but I've got another one buried. Nice. So there's different things to try out. It's good.
Yeah, Dolph is asking if you can spare him one.
Yeah,
we need to send you one, Dolph. So don't worry, we're gonna make sure in the next batch you get one.
Yeah, no, these I'll get the apart from this one, the others will get deployed shortly, so they can be people can sort of have a look at what's going on. Could probably put webcam as well, so you can actually see it.
Nice. Yeah, I'm wondering, like, did you try it with the batteries, and like, did you like have some sort of setup where it's actually functional and sending data?
Oh yes, no, it has. This first one was well exercised about a month ago.
Nice.
But I tend to work a quarter ahead, and all of these new things mean that I have to find little slots to squeeze things into. I don't have an UTI, so I've got other tools, but usually, these boards. You put them out in the field, and by the time you 3 years later, technology's moved on, let alone whether the batteries have run down. So it's sort of trying to find that balance between how long do you want it to last. But as I say, it's sort of just getting a few ideas of something interesting to measure.
Okay.
So,
thanks.
Yeah.
Sounds great, and thanks for the compliments. It's you were too kind.
No.
No, Nick is one of the active moderators on the forums, and he has been always like, of course, he's one of the first one who wrote down like unboxing of the generic node Sensor Edition. I remember the title, like not a video, so that was a funny one. Yeah, maybe you in the official, when we send you an official one, you can actually do a proper video unboxing and like a demo on YouTube. That would be awesome, I think.
Yeah, well, I mean, I think these are pretty official, aren't they? I know they're the first spin, but you know, it's what's not to like.
Cool. Thanks.
You're welcome.
So yeah, is there anybody else? Because we have only a few minutes left. So Ahmed, what was your plan here?
That's the last slide, to be honest. I'm happy that like Nick joined, and happy that we had some questions. Yeah, if you guys have anything else, yeah, we're gonna stay always things interested, and you can also like reach out to us and just help you out with stuff, of course. But yeah, we're trying our best to get to you for sure.
Cool. So if there's no further questions, so we'll wrap this up, and we'll leave this session. And
yeah, like I think the final thing is Dolph is asking for a tour, so maybe you can Nick just give him like a brief like point to what you have in the background, maybe. I think he's interested as a hardware engineer on that.
Yeah, so you're lucky because we're gonna have one conference 100% dedicated to the generic node end of June. Yeah, end of June. So we're gonna first have the conference around the Think Stack, and then we're gonna have a conference around the generic node. So yeah, join there as well, and then you will have a lot of tours, I guess. Cool.
Yeah, so we have a couple of questions. Nick, you wanna?
Well, no. If someone wanted to know what all of these boxes are,
yeah,
it's this is about a fifth of all of the storage of parts components. So I can just reach and solder. Nice. So we got the hot air soldering iron.
Oh, nice.
Yeah, super cool. Everything is within arm's reach. That's awesome. Yeah, that's really good. Yeah, so we have also some questions on the ordering. So we have someone saying, can you update us on the planning and shipping dates? So Wienke, you have any updates there?
Yeah. So there is. We're aiming to have them now ready somewhere in June. But nothing is certain. So this with the current state of the component shortage, there's nothing sensible to say here. So that's where we work for, and we work hard to make it as early as possible. But yeah, there are some externalities that we can't influence. So now, if you did a pre-order, that's your discount on your next on ordering it, and is on the list, and that still stands. And but yeah, it's hard to say any dates, unfortunately.
Cool. I think it's time to wrap it up. I would like to thank everyone who joined. Thank you for also your feedback. This was really awesome. Thank you, Wienke. Thank you, Orkhan. Thank you, Nick.
Thank you, guys. Thanks, Nick.
Thank you.
Really nice to have you here.
Thanks for everyone who joined. And yeah, hopefully see you in the next conference.
Okay. Bye.
Thank you, guys. Bye.
Bye, everyone.